Before construction can start on a building site, that site has to be levelled. This involves either the physical movement of material on a site to produce a flat surface, or the calculation of different elevations or reduced levels on a sloping site. The purpose of any levelling procedure is to produce a reference surface or plane. The reference plane can be real, such as the levelled building site, or the plane can be an imaginary one located above the site. In either case, the reference plane is a level surface from which elements of the building are measured. The concept of level relates to the surface of the Earth. However, the Earth's surface is not smooth. So it is easier to think of a level surface as one which is parallel to the surface of still water. Another way to think of a level surface is one which is at right angles to the force of gravity. A plumb bob is a weight hanging freely on the end of a string line. A plumb line indicates the force of gravity acting towards the centre of the Earth. Because the Earth is a sphere, this means that a level surface would have to curve to follow the Earth's surface. In practice, however, because of the relatively small size of a building compared to the size of the Earth, it is assumed that a level surface is flat and can be represented by a straight line or a two-dimensional plane. Different tools and techniques are available to define level surfaces or reference planes. Which one is used will depend on the job to be done and the degree of accuracy required. One of the more commonly used levelling tools is the spirit level. It is basically a straight edge of wood or aluminium fitted with at least two slightly curved glass tubes. Each tube is almost completely filled with liquid, leaving a bubble trapped inside. When the bubble is centered between the two lines marked on the tube, the level is giving a true reading. With the spirit level in a horizontal position, the reading is said to be level. When the spirit level is held vertically, the reading is said to be plumb. The effective length of a level can be extended by using it in conjunction with a straight edge. With the bubble centered, the reference plane can be either the top or bottom of the level or the bottom of the straight edge. The accuracy of a spirit level can be checked by taking a reading. The level is reversed and a second reading taken. If the bubble is not centered for the second reading, the level will need adjustment. To compensate for any minor error that may exist, it is good practice to reverse the level for alternate readings. This averages out any minor error that could otherwise be compounded. A spirit level can be used on its own or in combination with a longer straight edge to span greater distances. Measuring the difference in elevation between widely separated points on a slope can be done using a spirit level. The slope is divided into manageable steps. The vertical rise of each step is measured to the spirit level and recorded. The individual recorded heights are added together to give the overall change in elevation. Placing a spirit level on an object and sighting along it can give a reasonably accurate level over a short distance. A line level is a small spirit level which can be hooked over a string line. The line is stretched taut between 2 points. The level is placed in the middle and the reading taken. The reference plane in this case is the string. While it gives an approximate level, a line level is not an accurate instrument for levelling. The water level, or hydrostatic level, is simply a length of flexible clear plastic tubing. The tube is almost completely filled with water. It is important that all captured air bubbles be released from the tube. To do this, both ends of the tubes are raised to retain the water. Any trapped air can be worked to the ends by continually lifting that part of the tube immediately ahead of the bubble. The air will travel upward towards the end of the tube where it will be released. Alternatively, the tube can be charged directly from a tap. Water pressure will ensure a bubble-free tube. Food colouring can be added to make reading the water levels easier. The water level in the tube is read from the bottom of its curved surface. The hydrostatic level relies on the principle that water always finds its own level. When the two ends of the tube are held side by side, the water levels in each end correspond. The height common to these two levels represents the reference plane. When transferring levels, the water level in one end of the tube is fixed on or near the required reference plane or datum. The destination end of the tube is adjusted and the reference level marked. Because the two levels are in the same reference plane, elevations above or below them can be conveniently measured. Transferring levels around obstructions creates difficulties. Calculating the amount of packing needed to restore a house to level is an ideal job for a water level. The flexibility of the tubing allows levels to be established even when the datum level is obscured from line of sight. Boning rods are T-shaped frames of equal height and are generally used in sets of 3. They are used to determine additional heights or levels in a straight line when two initial levels are known. Boning rods are not a precise method of levelling.
Got to go down another 100 mil there.
However, they are ideal in some horizontal applications, such as levelling the bottoms of trenches for footings or pipes. Rods are placed on the two known levels and their crossbars sighted along. Adjusting the crossbar of the third rod to this line of sight produces an additional height or level. The line of sight between the crossbars on the two known stations creates the reference plane. Working parallel to this gives a straight bottom to the trench. The automatic level is a precision instrument that produces an extremely accurate reference plane. The level is set up on a tripod of telescopic legs that allow it to be adjusted to sloping ground. The tripod legs are trodden firmly into the ground to ensure a stable work platform. The tripod head need only be approximately horizontal. Some adjustment of the legs may be required. The level is mounted on the tripod and secured with a fixing screw. Several adjustments must be made to the instrument to ensure it is level before it can be used. A circular bubble indicates when the level is exactly horizontal. Centering the bubble is done by turning 3 adjustable foot screws. The level is rotated until the sighting groove is lined up parallel with the axis of 2 of these screws. These screws are rotated as a pair, either both inwards or both outwards. The direction the left thumb moves while turning indicates the direction the bubble will move. The bubble is brought into line with the centre circle. Turning the screw on the opposite side brings the bubble to centre. The instrument is now level. The telescope is adjusted to suit the operator's eyesight. This is done by looking through the eyepiece and turning it until the crosshairs are sharp and black. The centre crosshairs are used when taking levels. Lines called upper and lower stadia cut the vertical crosshair horizontally and are used to measure distance. Initial aiming at the staff is done using the sighting groove on top of the instrument. The focusing knob is located on the side of the instrument. It is turned until the staff is brought into focus. Final aiming at the staff can be done using the horizontal drive knob. This knob makes fine adjustments and is extremely accurate. In use, the operator's line of sight through the telescope is the reference plane. As the staff is moved to different stations on the site, measurements are taken above or below this reference plane. If the horizontal distance from the instrument to the staff is required, it can be found using the stadia. The stadia readings are taken and the difference between them calculated. This figure is multiplied by 100 to give the distance to the staff. The laser level has the advantage of one-person operation. It is set up on its tripod in a similar way to the automatic level. The instrument is levelled by adjusting the bubble until it is centred in the circle. After a battery check is carried out, the instrument is turned on. The rotating laser beam generates a circular reference plane several hundred metres in diameter. A receiving device with a photocell is fitted to the staff and faced towards the level. When the receiver is turned on, a function check is displayed on the liquid crystal screen. Continued operation of the on switch selects the degree of sensitivity or accuracy required. In use, the receiver is adjusted vertically in the direction shown by the on-screen arrows. These arrows are accompanied by a pulsing audio signal. The sound changes to a continuous tone when it is located exactly in the reference plane. The need for only one operator and the high degree of accuracy make the laser level an economical and effective instrument. Laser levels are often used in conjunction with earth-moving machinery in site levelling. The receiver is mounted on the blade and lights are used to indicate when the correct level is achieved.